Now, guys, you can see here. First, we are going to cover here. We are going to look for aerospace as well as for you know mechanical. So in aerospace, basically, no, it is just a demo class for fluid mechanics, right? We're gonna have the regular classes after the engineering mechanics. No, will be getting finished. The moment engineering mechanics will be finished, we will be starting fluid mechanics, right? So this is just a demo class for fluid mechanics, right? So that you can get to know what all the things are there, what all the basics of fluid mechanics. So FM syllabus for aerospace, that is there in the section 4. In the section 4, we have the broad classification like aerodynamics, right? If you see here, we have the broad classifications. We have the section 1, section 2, section 3, section 4. Section 4 is basically aerodynamics. Under aerodynamics, we have 3 to 4 topics. One of the topic is basics of the fluid mechanics. In the basics of the fluid mechanics, the core topics are the conservation laws, mass and momentum, and energy theory. And then we have what? Dimensional analysis and dynamic similarities. Please make a note of it, the syllabus part. Under the core topics of aerodynamics, that is the core topics of basics of the fluid mechanics. You can see here the basics of fluid mechanics. So whatever the topic I will be going to cover will not be covered by aerodynamics faculty. He will be covering the remaining part of this aerodynamics, right? And it is a very important, not only for the fluid mechanics point of view, but for the aerodynamics point of view also, right? And I have been associated with the iitiansgateclasses classes for the 3 to 4 years, and before that also I have taken the fluid mechanics for you know a mechanical branch. So on the basis of my experience, I can say that whatever the topic, whatever the things, and whatever the content I am going to cover in the class will be more than sufficient enough for gate exam, right? Coming back to the topics, mass and momentum and energy conservations, right? These are the conservation laws. In this one, we are going to have two format. One is the integral form, other is a differential form, right? In our particular classes, I'm going to cover the differential form, and this integral form will be covered by aerodynamic faculty regarding mass, momentum, and energy, right? Then, my different, we are going to cover the topic called dimensional analysis and similarities. But by looking at the syllabus part, you might be thinking, sir, there are only two topics, major two topics: conservation laws and dynamic similarities. That is, you know, dimension analysis and dynamic similarity. But we are going to, frame the sequence in such a manner that we can cover this basics of the fluid mechanics in 9 chapters. What are all the 9 chapters? The first is, you can see here, the fluid properties. The fluid properties. Then we are going to cover the fluid statics. Fluid statics. Then we are going to cover the fluid kinematics, fluid dynamics, basics of the laminar flow, flow through pipes, flow through pipes, dimensional analysis and similarity, boundary layer theory. What is a BLT? Boundary layer theory. Boundary layer theory. Then we are going to cover the basics of turbulent flow, guys. The basics of turbulent flow, right? Although they have not mentioned each and everything, but they keep on asking the question from fluid properties and fluid statics. This year they asked in GATE 2024, they asked the question from these two topics for 4 marks. One question is from the boundary layer theory, other question is from the dimensional analysis and similarity. Once it is done, let me know. Is it done, guys? Perfect. So that is a FM syllabus, fluid mechanics syllabus for aero. Now moving on to the mechanical, some of the students from the mechanical also will be here. So I will be taking here. See, for mechanical, they have mentioned each and everything clearly. Under the section 3, fluid mechanics and thermal science. In this one, fluid properties, you can see that fluid properties, fluid statics, forces on submerged bodies, stability of floating bodies, control volume analysis of mass, momentum, and energy. Then fluid kinematics. Under fluid kinematics, so we have to discuss fluid acceleration, differential equation of continuity and momentum, Bernoulli equations. Under the fluid dynamics, dimensional analysis and similarity once again, the viscous flow of an incompressible fluid, boundary layer, elementary turbulent flow, flow through pipes, head losses in the pipes, bend and fitting, then basics of compressible fluid flow. Basics of the compressible fluid flow I will be covering separately for mechanical, not for the aerospace, because you are going to cover anyway in the gas dynamics, right? Please make a note of it. So anyone here from mechanical? Yes, I will be covering all the basics with the numericals. No need to think about, no need to have a single doubt about that. Anyone is here from mechanical? Yes, I will be covering both the syllabus. Whenever I will be taking class for fluid mechanics, let's say I will be taking, I know, basically approximately uh, like 12 to 13 classes, you know, for this particular fluid mechanics. Approximately 12 to 13 classes. In this 12 to 13 classes, I will be covering both mechanical and aerospace portion, which are common to both of them. Then after that, I will be taking separately for mechanical. Right. So all of you have noted down. This is the fluid mechanics syllabus for mechanical. Done, guys. All of you have noted down. Perfect, guys. Now, before starting, anyway, I will be taking this particular thing again once again in the lecture number one in our regular classes. But why I'm discussing, I just want to give you the references books, for fluid mechanics, and try to have a book at least for each and every subject, so that you can always cross check whatever it is happening in the classes with the textbook. So a standard reference book, the first book is a famous book. Everybody must be aware of that. The Unis, Sinjal and Simbala. This book is basically for concept and numerical. Both you can follow. Then we have the second book, that is a Frank and White. This is the most fundamental book for fluid mechanics and good number of numericals. That means high standard numericals are given in this particular textbook. Right. Then third we have Eskesom, Eskesom and Biswas Chakravarti. That is also one of the fluid mechanics and hydraulic machine book by IIT Kharagpur professors. Then the fourth reference book is K. Subramanyam. That is K. Subramanyam means it is only for problem. We have the thousand problem, basically regarding fluid mechanics. Then we have the R.K. Bansal only for the basic numerical. Now, the purpose of mentioning here five books is not to confuse you. It is just there for the references, right? I will not be strictly telling you to follow only the unis, Sinjal and Simbala. But my suggestion is that you try to follow this particular any of these two books, any of these three particular books, any one of them. They are the very very important books. For mechanical, SK Som and Biswas and Chakravarti book is very very mandatory because directly the question is coming from this particular textbook in the GATE exam. Regarding aerospace, they are basically taking the question from Sinjal and Simbala and FM White. Right. Then if you have sufficient amount of time after practicing from particular textbook, and after practicing the question from the classroom, then you can follow K. Subramanyam for the problem. But remember, there are a lot of mistake in calculation and in the final answers. So be aware of that. Anyway, we have the WhatsApp group for basically clarifying the concepts and for the doubt sessions. Whatever the things are there, you can discuss in the respective groups, right? Right. So if you ask me, the book that need to be followed is FM White, one of the best book. If you can able to follow that, if you are able to understand the language of that book, nobody can stop you to get the good rank in GATE exam. One of the very good book for fluid mechanics. But if you are not able to understand, then the simpler version of this FM White is Sinjal and Simbala. And my suggestion is that not only for this subject, for all the subjects, you should have at least one reference book, a standard reference book. Right. Once it is done, let me know, please. That is also one of the good book. The Fox and McDonald is also one of the very, very good book. If you are following that, you can keep following that also. No need to worry. Can I move to the next one?
Excuse me, sir.
Now, guys, the weightage part, if you see, the weightage for aerospace generally it is varying from 3 to 4 marks or 5 marks.
Excuse me, sir.
But in GATE 2022, they asked for 7 marks. I'm talking about aerospace paper. Regarding the fluid mechanics, they have asked a huge number of questions from basics of the fluid mechanics, that too of 7 marks. For mechanical, it is varying from 6 to 9 marks. Right. Now, what are all the sources for practicing the question? Right. And coming to this GATE 2024 fluid mechanics, they have asked for 4 marks. Two questions were asked, that is of 2 marks. What are all the sources for practicing the question, guys? One is the IGC notes and questions. Whatever the notes and question I will be sharing, not only this subject, other subject also. They are very, very important. Second is GATE previous year questions. The GATE previous year question of aerospace, XC, engineering science, mechanical and civil. All you have to follow. All you have to just solve it. The third is NPTEL assignment question that I will be sharing separately in the Google Drive. The fourth very very important thing is that the test series. Further, if you have further time, then you can follow ESC Engineering Services previous year question for strength of material and fluid mechanics. Why I am mentioning that one? Because for a multiple select question, you can follow that one. Then sixth we have the IGC assignment. Right now, why it is very very important and essential to solve IGC assignment? Because this IGC assignment has been made from a standard reference book. Standard reference, standard reference book. Whatever the question they have given in this IGC assignment, they are taken from the standard reference book, right? And these are the my different unsolved good questions from the respective books, the standard books. Because as a human being, it is impossible to judge a question at the initial level. That too, when you have the thousand unsolved problem, it is very difficult to choose a very good numerical out of that for each and every topic. Then it is very very essential to have IGC assignment, and to solve that particular assignment, because the good questions are there from the standard reference book. Directly you can solve that, and you can have a command over each and every topic rather than solving each and every numerical from the unsolved example, because practically it is impossible. Otherwise it will take completely 1 year for basically completing the one particular subject, and it is not advisable. All of you understanding my point? Initial 20 to 30 minutes will be like this only. You have to bear with this, because these are the most essential part. Anyway, we are going to cover the topic. No need to worry so much about the demo, sir. You are not covering any topic. You are keep on talking about this thing. These are the very, very important, very, very essential thing, right? Coming back to the important point, the IGC notes are highly, highly recommended. Test series is a 5 star. Then gate previous year question 4 star. NPTEL assignment 2 star. IGC assignment again 5 star. Based on the importance, I have given this star mark. Please make a note of it. Once it is done, let me know, please. Yeah, that is what Bhavya here I mentioned, that you need to follow the IGC assignment. You have to solve the IGC assignment. Now, guys, In today's session, let us not complicate this session, and we will be starting with the very basics, that is nothing but fluid property. Note on chapter number 1, fluid properties. In this particular session, under chapter number 1, we are going to cover the basics of the basic property of the fluids. We are not going to cover the concept of quantum, right? And then we are going to cover the working knowledge of viscosity and the consequences of frictional effect it causes in a fluid flow. So basics of the basic, what are the property of the fluids and the viscosity property. These particular two things we are going to cover in this particular session, guys. Please make a note of it. Done, guys. This year gate paper you're saying? This year gate paper you're saying? This year they have asked the two questions from the fluid mechanics. One question from the boundary layer theory. One question is from the boundary layer theory, and second is from the dimension analysis and dynamic similarity. Note on the basic concept fluid mechanics. Note on fluid mechanics. Before discussing the fluid mechanics, we are going to cover first of all mechanics. We are going to cover the mechanics. Yes, in aerospace. What is the mechanics? Engineering mechanics already started, so everybody know what is the meaning of mechanics. It is a study of effect of forces. It is a study of effect of forces, guys. Now we can study this effect of forces in three particular conditions. One, when the body is under rest condition. Second, when the body is under motion condition. Third, when the body is under what, guys? When the body is under deformations. Right? There are three states is possible for any body. Body can be under rest, body can be under motion, body can be under deformations. Please make a note of it. Now, in the engineering mechanics, already engineering mechanics is started, right? Engineering mechanics already started, right? Now, my different, what we have studied or what you are studying till now in the engineering mechanics, you might have studied, right now you're studying engineering mechanics, basically dealing with the non-deformable bodies, rigid bodies. When the body is under rest or motion, those type of motion we are doing, those type of analysis we are doing in the engineering mechanics. What about deformation? This deformation we are going to study in the strength of material. Strength of material. That means in the strength of material, we are dealing with the deformable bodies. Deformable bodies. Now, what is the meaning of deformable and non-deformable bodies? For example, we have a cantilever beam. Suppose we are applying the end moment. The beam will bend like this. If we take a 2 point, point A, point A dash, point B, point B dash. Let's say after bending, the beam gets bent. Now tell me before whatever the distance between A and B, for example L, now tell me the distance between A and B is getting changed or it is remain same. Try to answer it. It will definitely change. Whenever the distance, whenever the relative distance between the 2 points of a same body is getting changed, that body will be called as what? Deformable bodies or non-rigid bodies. Non-rigid bodies. Same particular example number one, that is a cantilever beam. If I change the support, if I change the support in example number two, let's say a pin support. Again, same movement we are applying. So it will be rotated like this. If it is rotated, my dear friend, what will happen? The distance between A and B will not be getting changed. It will remain same. It is just getting rotated. That's it. So this type of motion we are doing what? This type of motion we are doing in the what? Engineer mechanics. Engineer mechanics. But what about this type of motion? We are doing the analysis in the strength of material. Now you might be thinking, so what we are doing in the fluid mechanics then? In the fluid mechanics, we are studying all three. Fluid mechanics is a subject in which we are dealing with the body which are under rest, motion, and deformations. Please make a note of it. In fluid mechanics, all the three is it's basically its states are possible. That means whenever the fluid is under rest, that is the fluid statics. Whenever the fluid is under motion, that is the fluid kinematics, and the fluid is under what? Continuously deformation, guys. That is what we are calling fluid flow. So these are the very basic thing regarding the fluid mechanics, guys. We are going to see the definition of the fluid also. See, the special thing about my classes is that whatever the thing I'm discussing in the slide, each and everything is important for get exam. Anything can be picked from my slide and can be framed in the form of question. I don't have time to give the proof because right now we don't have that much time. But once the regular session will be started, I will be started giving giving you the proof. Each and every point is important of my slide. Mechanics of solid, mechanics of solid, mechanics of fluid, and the engineering mechanics. You should know the difference between these three subjects. Correct. I will be discussing. I will be moving on to that only, whether it is having a fixed deformation or a continuously deformations. That continuous motion which are happening, that is one type of what? Deformation only. Very good. See, you take a fluid body and you just apply the force. However, very, very small force, you try to think that is a fluid. What will happen? It will continuously deform. Continuously it will deform. And that deformation only will cause the fluid flow to be begin. That's how we say that the fluid is flowing. That means fluid is continuously deforming. Suppose you are not applying any shear force, then the fluid is under what? Rest condition, right? The fluid is under what, guys? The fluid is under rest conditions. It cannot resist shear force. Very good. Just like a solid body can resist the shear force. That's why the shear stress is being introduced. But what about here, guys? The fluid particles cannot resist the shear force. The fluid particle cannot resist the tensile force also. The fluid particle can only resist the 3D compressive force, the three dimension compressive force. All of you have noted down?
Excuse me, sir.
The Mohr circle is for what, guys? When we are discussing the hydrostatic state of stress condition, as of now, I'm not talking about the any stress part. If stress is not coming, we cannot discuss anything regarding the Mohr circle, right? Now, all of you have noted down, guys. Can I move to the next one? Please let me know. Now, guys, try to note down the definition of the fluid. The fluids are the substances that deforms continuously under the application of a tangential or shear force, no matter how small is the value of applied tangential force. Now, understand the difference between solid and fluid. Try to understand. Yeah, Bhavasi, I'm discussing here right now the fluid, and coming to here, let's take a body, a solid body. Let's take a fluid body, and you try to apply the tangential force. Let's say you are applying the tangential force. Here also you are applying some kind of tangential force. Now, my dear friend, try understanding. Whenever you apply the tangential force to the solid body, definitely some deformation will be there. The body will be getting deformed like this, and there will be some shear deformation will begin. There will be some shear deformation will begin, which is nothing but shear strain. What is the shear strain and all? No need to worry. Try to understand as of now these things. When we apply the shear force, because of the shear force, there will be shear stress will be developed, which is obviously equal to force over area. This particular deformation is a fixed deformation. Whatever the deformations are happening, these deformations are a fixed deformation. Why? Because every solid body is having certain amount of elastic property, which is nothing but what? Tau is g times of gamma, where g is what? Shear modulus. No need to worry. We will be discussing each and everything in the strength of material, guys. Right now, my dear friend, this gamma, whatever the value gamma is there, which is nothing but tau over z, this g is having a fixed value. If it is having a fixed value, you are applying a fixed quantity of f over area, then this shear deformation will also be having a fixed value. That means in the solid, the deformations are fixed. The deformations are fixed. It is not deforming continuously. But my dear friend, in the fluid, what is happening? The same fluid, whatever the fluid you have taken, and you just apply the same tangential force, the fluid will be deforming continuously. Continuously, it will be start deforming, right? Continuously deforming. Now the question is why it is continuously deforming? Because there is a no fluid property called shear modulus or something like that. And this continuously deformation only, this continuous deformation only we call the fluid flow has begun. Fluid flow means motion. Please make a note of it. Very, very important. So that's the difference between solid and fluid. Is it done? Okay, guys, understand. Deformations are fixed. There is a continuous deformations. Continuous deformations. Note down. The next particular topic is property. Any characteristic of a system is called a property. There are basically two types of property. One is the intensive property, second is extensive property. One is intensive property, second is extensive property. What is the meaning of intensive property? Intensive properties are those property which are independent of mass of the system. The name itself is there, shortcut is there. Independent. Intensive means independent of mass of the system. What is the example? Temperature, pressure, density. Now to explain this intensive property, let me take one example. Suppose there is a room. Basically in this room we have the air which are there at a certain pressure and temperature. And this room is having a fixed volume, for example volume V, right? The same room, if I divide into two compartment or two room which is having a volume V by 2 and V by 2. Now tell me, the same air will have the same pressure temperature, or pressure and temperature will be divided by half. Let's say we have the mass of the system m, but after that the mass of the system is m by 2, m by 2. The mass is getting reduced by half, but still the pressure and temperature of the room will remain same. You cannot change the pressure and temperature of this atmospheric air which are there in the room. Are you getting my point? So pressure, temperature, and density. Now, why density is having intensive property? Because density, if you write, which is equal to mass by volume, mass is nothing but extensive property. Why it is an extensive property? Because it is depending on size or extent of the system. Size or extent of the system. What is the example of extensive property? Total mass, total volume, total momentum. The ratio of two extensive property, mass and V, they are the extensive property. The ratio of two, put a note point and write down. The ratio of two extensive property will be will be called as intensive property. That's why the density is what? Coming under intensive property. Can you tell me some other example? Can you just give me some other example for intensive properties? If I write down the viscosity is a fluid property. Again, it is not depending on the mass or size of the system. Whatever the fluid viscosity is there will remain same for after dividing the room also. Specific enthalpy. which is nothing but kilojoule per kg. Once we have divided by mass, it is not depending on the mass. It will become intensive property. Yeah, viscosity, dynamic viscosity already have written. Can you give me the more example regarding this extensive property? Total momentum. What is the meaning of momentum? Momentum means mass into volume. Both are what? Extensive property. Some of the other examples are, you have the kinetic energy, because kinetic energy half of mv square, again mass is coming, it is depending on the mass, right? Then by definition you have the total enthalpy. Total enthalpy, very good. Potential energy, right? Mgh, they are basically depending on what? Mass of the system, guys. Please make a note of it. See, what about the internal energy? What about the internal energy, guys? Whether it is a property or not? Yeah, it is a property. But which property? If you know a little bit about the thermodynamics, then definitely you can able to answer, guys. See, internal energy is what, guys? Internal energy, if you talk about the internal energy, again it is also what? Extensive property. But if you write the specific internal energy, that will become intensive property. Getting my point? All the specific properties, all the specific properties are what? Intensive property, right? Specific enthalpy, specific entropy, specific internal energy, these are the intensive property. Total energy, total enthalpy, total internal energy, these are the extensive property. Getting my point? Are you understanding? Why? Yes. Internal energy is nothing but extensive thermodynamic property. Are you getting my point? If it is a specific, then we are dividing with a kilojoule per kg, that will become intensive property. But overall, it is a property, thermodynamic property. See, whenever we write internal energy, we write MCT, MCV into T, for example. It is depending on the what? Mass. But whenever we write U by M, specific internal energy, that will become CV times of T. Are you getting my point? So that will become intensive property. But for that, I need to discuss again thermodynamics. Already thermodynamics classes will be happening for you. No need to, again introduce the thermodynamics over here. See, two diagram means there is a room which is having a certain volume V. In that room, suppose you are sitting right now in the particular room and you are watching this session. You are surrounded with the vacuum, or you have some surrounding air. Definitely air. that air is having some viscosity, that air is having putting some kind of atmospheric pressure and some temperature. Now tell me, when you divide this your room in which you are sitting right now, whether pressure and temperature of that room will become half or will remain same after dividing your room into two exactly equal part. It will remain same. So it is whether it is depending on the size or mass of the system. No, right? So that should be what? Intensive property. That is what written here. Temperature, pressure, and density. Getting my point? Is that clear? To explain the concept of intensive property, I have explained by using the example, this room example. Can I move to the next one? Please note down the next concept. That is nothing but next property, density. Note down the next property, density, guys. Everybody know density is what? Mass per unit volume. Density is mass per unit volume. But if I take the reciprocal of that, it will become V by M, which is nothing but specific volume. Specific volume V. You can just keep it like property number one. Now, property number two is specific gravity or relative density. Specific gravity or relative density, guys, which generally denoted by S. What is the definition of S? Density of fluid. It is the ratio of density of fluid to the density of standard fluid. Density of any fluid to the density of standard fluid. Now, which fluid to be considered as standard fluid? In case of liquid, we generally consider density of water at 4 degrees centigrade. But what about the density of, in case of gases, we generally consider ideal gas density as a standard fluid, Wherever if you want to measure the specific gravity of any gases, the standard references fluid will be ideal gas. But for the case of liquid, we consider we consider a standard fluid as water. At 4 degrees centigrade, the density of water is maximum, which is nothing but 1000 kilogram per meter cube. For the gases, the standard fluid will be ideal gas, ideal gas density, right? At the standard temperature and pressure. Specific gravity, relative density, both are having same meaning. Can I move to the next one, guys? Can we discuss the next property? No, the physical significance is that we can compare any density of fluid, any fluid density with a standard fluid, right? How heavier that fluid is, right? How heavy that particular, your fluid is. That is what it is basically. If you talk about the density, it is telling you how heavy this particular fluid is. Now, on the next basically term in the property column, the weight of a unit volume is called specific weight. Specific weight. The specific volume means it is a reciprocal of the density. It is a reciprocal of the density. How much of volume is there for a unit mass, right? That is being denoted by specific volume. Generally, the value of density of ideal gas is 1.2 kilogram per meter cube. Getting my point? Specific weight. What is the meaning of specific weight, guys? Specific weight means gamma s will be weight per unit volume. Weight is what? Mg over volume. Now, what is the gamma s? Mg. What is the m? Volume into density into g over v. So this v will be cancelling out. We are going to left with the what? Rho g. So specific weight is basically what? What is the unit? The unit should be weight per unit volume. That means Newton per meter cube. If you write in the dimension format, what should be the dimension for this? What is the dimension of weight mg? Mlt minus 2. And what should be the dimension of volume? L cube. So if you are going to write, it will be ml minus 2 t minus 2. How we are getting ml t minus 2? What is the mass? Mass is m. What is the z? What is the g, guys? Gravitational value, right? G value is what? Meter per second square. What is the unit? Meter per second square, which is nothing but L t minus 2. So it will be mlt minus 2 if we talk about mg. And in the denominator, we have the volume, which is nothing but L cube. Which one is the second formula here? Gamma S. What is the gamma S? Weight per unit volume. What is the weight of any fluid? Mg. Mg over volume. What is the mass? Mass, you know that volume into density, right? Into G. So volume and volume will be cancelling out. We are going to left with the what? We are going to left with the rho into G, right? What is the unit? Newton per meter cube. If you write in the dimension format, it should be ml minus 2 t minus 2. Getting my point? See, if you talk about the specific volume, weight, right? And what else you want the differences? See, weight is mg. The specific volume means whatever the volume is there per unit mass. That is a small v, right? A specific volume is basically an intensive property which is defined as the ratio of what? A substance volume to its mass. But weight is what? How particular total weight of a particular fluid element, that is denoted by what? Weight. But how much of volume is containing per unit mass, that is a specific volume. That is a specific volume. Are you understanding? Where exactly the use of a specific volume? In basically thermodynamics. Whenever we are dealing with the what? The topic called, pure substances, there the specific volume use is what? Use is very, very high, right? Other differences are specific volume is an intensive property, but what about the weight? It is a extensive property. Getting my point? The specific volume is the reciprocal of the density. That means what is the meaning of density? How heavy your fluid is. The specific volume is how lighter your particular fluid is. That is what the reciprocal of heavier term, right? If you talk about the theoretical sense, that will be the meaning of specific volume, right? Specific means per unit mass. Whenever you are dividing any quantity, if you are writing enthalpy, total enthalpy over mass, that will become specific enthalpy. Whenever you are writing specific entropy, for example, S by M, that will become what? Small s, right? Also, for example, ds by m, that will become small ds dash. That will become specific entropy. Total entropy, if you divide by mass, that will become specific entropy, right? Why we use it? That is history. I'm not aware of that, right? But whenever we use the prefix call, basically specific, that means we are dividing with the mass. No, SI unit you for which one? Specific weight you are asking? SI unit for which one? For specific weight? Specific weight, you are going to get the Newton per meter cube, right? Why you are not getting? See that. Rho g. If you just take the rho g also, rho g is what? What is the density unit? Kilogram per meter cube. What is the g value? Meter per second square. Kilogram meter per second square. Already you know that it is a unit of what? Newton over meter cube. So what are you going to get? Newton per meter cube. That is the SI unit of specific weight, right? Is that clear? Please note down the density of ideal gas. How to calculate the density of an ideal gas? By using the ideal gas equations. What is the ideal gas equation? PV is equal to what? MRT. If we divide by M, we are going to get P into V, which is equal to R into T. The important thing is that P is what? Absolute pressure. V is the what? Specific volume. T is what? Thermodynamic absolute temperature. Rho is the density. R is what? Gas constant. Gas constant, which is nothing but universal gas constant over molecular weight. Generally, what is the value of universal gas constant? 8.314 kilojoule over kg Kelvin. But the very good thing is that P is what? Absolute pressure. Now, what is the meaning of absolute pressure? Absolute pressure or total pressure. We will discuss in the fluid statics, that is the second chapter, that P absolute will be written as P atmospheric pressure plus P gauge pressure. Make a note of it. Now we will try to understand what is the gauge pressure and what is the atmospheric pressure. For example, there is a certain place. At that certain, no, basically at that particular place, we have the atmospheric air, and atmospheric pressure is 100 kilopascal. Suppose, for example, at that location, and I'm saying that the total pressure at that location is, let's say, 120 kilopascal. I'm just mentioning that with respect to zero reference, the total pressure is 120 kilopascal, but atmospheric pressure is what? 100 kilopascal. With respect to atmospheric pressure, how much of extra pressure is there? 20 kilopascal. That 20 kilopascal will become what? Your gauge pressure. That 20 kilopascal will become what? Your gauge pressure. This gauge pressure can be positive, can be negative, but absolute pressure will always be positive. Suppose if I say at a particular location, at certain location, my pressure is, for example, if I say that pressure is 20 kilopascal, then what you will understand? At that location, whether there is a vacuum or a fully occupied space is there. Think about that. I mentioned that at that location the pressure is 20 kilopascal. That means that is the total pressure. Total pressure, we know that atmospheric pressure. And what is the local atmospheric pressure? The local atmospheric pressure at that location is 100 kilopascal, for example, plus P gauge pressure. That this is a 20 kilopascal, 100 plus P gauge. What is the P gauge? It's a minus 80 kilopascal. That means you can also say that, or there is a vacuum pressure of 80 kilopascal at that location. If you say vacuum pressure of 80 kilopascal, definitely everybody can understand, okay, 100 minus 80, 20 kilopascal is the net pressure, total pressure available at that location. That will become your what? Absolute pressure. Suppose if you mention somewhere at a particular location, my particular total pressure is 120 kilopascal. Everybody can understand, okay, At that location, so atmospheric pressure is 100 kilopascal, and you are saying 120 means more than atmosphere means there is a what positive gauge pressure. Are you getting my point? So gauge pressure can be negative, can be positive, but the total or absolute pressure will always be positive. Right? Please make a note of it. So in this formula, P should not be gauge or atmosphere; it should be absolute pressure. That is a very important point. The negative gauge pressure will be called as a vacuum pressure. Vacuum means there is a negative. That's the name is that's why it is the naming is given as vacuum, right? The vacuum is what? It's a negative value, right? Nothing is there. Can I move to the next one? All of you have noted down. Note of the next property, which are very important property called dynamic viscosity or viscosity. Dynamic viscosity or viscosity. First of all, note down the each and every term which are given in this slide. Then we will discuss. To explain the fundamental concept of viscosity, I will be giving you the example of engineering mechanics, which you might be already knowing that whenever any solid body is kept on rough surface, and now the moment you just apply the force F, definitely you will find some friction force offered by the rough surface onto the solid object. Whenever the motion will be started taking place between the solid object and the rough surface, because of the rough surface will offer some kind of friction force, and it will try to oppose the motion of the solid object. That is what happening in case of solid mechanics, or what we call engineering mechanics, or in case of solid world. But what will happen with the fluid? What will happen with the fluid? Let's say you have a plate. This plate is being fixed, and in between these two plates we have a fluid. We have a fluid, for example. The fluid is having a certain property called viscosity. Try understanding. The moment you try to pull this plate, upper plate, with the constant force F, with the constant velocity V, the plate will be started moving. What about the plate near to the plate, or whatever the upper plate, whatever the fluid particle is there? Let me show the fluid particle with this one. These are the fluid particle number one. Let's say the bottom of that means this layer, second layer, I am denoting with this one. That is the fluid particle 2. Try understanding, guys. Whenever I pull the upper plate, the top plate, with the force F and with the constant velocity V, what will happen? Tell me, guys. This fluid particle number 1 will have higher velocity than the fluid particle number 2, or lower velocity, or equal velocity at the first instant. Definitely fluid particle 1 which is being attached to the top plate will try to move with the same velocity as the top plate is moving because of no slip conditions. I will be telling you what is the meaning of no slip conditions. The moment fluid particle will observe, because initially what is there, they are the fluid particle, right? They have huge bonding between each others. What the communication will happen between the fluid particle 2 and fluid particle 2 and fluid particle 1? The fluid particle 2 will say, how can you move forward with such a high velocity? Can't you see we have the huge bonding between each others? You're not at all giving me any respect and you're moving forward. Because of that, it will try to offer some kind of what, viscous force or resistive force like this, so that it can stop the motion of a top plate. What about the particle, fluid particle which is being attached to the lower plate? Let me just say this is a fluid particle 3, and I'm drawing here the fluid particle 3 so that you can see the free body diagram of each and every fluid particle. Fluid particle 3, fluid particle number 3 will say that to the fluid particle 2, okay, you know that when the fluid particle number 2 will offer some kind of shear force or the viscous force or the resistive force on the fluid particle number 1, by the Newton third law, it will also offer some kind of what, the fluid particle number 1 will offer some kind of resistive force equal amount but in the opposite direction like this. Because of this green color shear force, the fluid particle 2 will be started moving what, in the forward directions. Then the fluid particle 3 will say, how you guys are seamlessly trying to moving forward in the particularly what, in the respective positive x directions. Can't you see I'm at the fixed location, I'm getting stuck with the bottom plate? And in that particular communication, what will happen in the conversation, the fluid particle 3 will offer again the what, the fluid particle 3 will offer some kind of what, resistive force to the fluid particle number 2. And what about the fluid particle 2 will offer? It will offer the resistive force equal but in opposite directions. So viscosity is nothing but the property of the fluid by means of which it offer the resistance between the fluid layers. Please make a note of it. When the two solid surface or two solid bodies are coming in contact and they started moving relative to each other, a friction force will be developed at the contact surface in the direction opposite to the motion. The situation is similar when a fluid moves related to the solid or when the two fluids move related to each other. The property that represents the internal resistance of a fluid motion is called viscosity. So viscosity will be coming into the picture whenever the fluid is in contact with the solid surface or two fluids are coming in contact with each other. Right? Make a note of it. All of you understanding my point? How to calculate the shear force, or we call viscous force, or the resistive force offered by the fluid particles? That is by Newton's law of viscosity. That is what we are going to discuss. Right? If both the plates are moving, then also there is a what? A resistive force will be developed. There is no doubt about it. See, if both the plates are moving, let's say with the same velocity, but in between fluid particle, they are at the rest, Initially, they are at the rest. Initially, here also they are at the rest position only. Why they are started moving? Why they are started to move? Because of the shear force, because of the force which we applied, because the upper plate is moving. When the upper plate will move, the fluid particle which is being attached to the upper plate will be started moving what, in the forward directions. Below particle will also be started moving in the forward direction because they are having the bonding. That bonding is called what, viscosity. Getting my point? Are you understanding, all of you? Now, in one case, my defend, even though even though you try to move it with the velocity, constant velocity, still it will offer no resistance when you are having ideal fluid. Let's say you have the ideal fluid which is having no viscosity. Though you try to move it with the velocity v, all the fluid particle, no, they are not going to resist the motion of a fluid particle which is being attached to the top plate, and all the fluid particle will be started moving with the same velocity v. The velocity profile will be what? A uniform velocity profile, and in that, so they will not follow no slip conditions. No slip condition will not be valid. Whenever we talk about the real fluid which is having a certain viscosity, then only this no slip condition will be followed. See, these are the small thing I used to discuss in the classes, right? One time in GATE 2022, they asked the question from this slide only. They asked the question from this slide only. Not believing? Let me show you that question. Ideal fluid means which is having a zero viscosity. In reality, it is not exist. Ideal flow may be possible, but ideal fluid is not possible. All the fluids are having at least some viscosity, whether it is a minimum or maximum, but it is having certain amount of viscosity. All of you have noted down so that we can discuss at least the question related to this stuff. Is it done? Ideal flow I will discuss once I will discuss the Newton's law of viscosity. Is it done, guys? Whether this slide is done? Now, in the Aerospace 2022 in GATE examination, they asked the question for 1 mark, and you can see that this question, no slip condition. Better you just note down the no slip condition. Here only you just note down no slip condition. No slip conditions. Whenever a fluid is flowing over any solid surface, or body, the relative velocity between fluid and solid surface will be big zero. Consider a velocity distributions. There is a two plate, for example, one plate is like this, other plate is moving with the velocity u, and the velocity profile is a parabolic velocity profile, and they have considered two fluid layer. One is a layer number one, other is a what, layer number two. Tell me which fluid particle is having more velocity. Definitely layer 2 particle is having more velocity, right? Now tell me, the viscous force exerted by the layer number 1 onto the layer number 2 obviously will be what? In the opposite directions. Tell me guys, where exactly it will be? Because it is moving towards the left, then definitely moving towards the right, then what should it should do? Layer number 1 onto the layer number 2. It should offer the viscous force in the opposite to the direction of motion. The motion is what? Rightward. It should offer the leftward what? Viscous force. B should be correct. But if they will be asking you what is the viscous force exerted by the layer number 2 onto the layer number 1, towards the right. See, whatever the things we are discussing, free body diagram, they are asking the question on that. That's why I'm saying whatever the things I'm discussing in the class, don't move beyond that. Try to be within the consignment of whatever the things we are discussing in the classes. That is a much beyond whatever the things are there with respect to what gate examinations, right? Getting my point? No, fully developed and all that concept will be coming when we discuss what is the meaning of fully developed flow. Here, there is no meaning of fully developed flow right now. See, we have the two fluid particle number L1, fluid particle L2. Tell me where exactly the direction of a motion? The direction of a motion is towards the right. By looking at the picture, this is the velocity profile, right? This is the, sorry, just a moment. Suppose you have a plate, one plate is fixed one, another plate is moving with the velocity u. The fluid particle L2 is near to the bottom plate or fluid particle L1 is near to the bottom plate? Tell me. Fluid particle L2 is near to the bottom plate. So definitely it is having more velocity than the what? Fluid particle L1. Let's say it is having velocity U2, it is having velocity U1. U2 is more than U1. Now tell me to stop the motion, to resist the motion, to decrease the velocity of fluid particle L2, L1 should offer the resistive force in this direction or in these directions. Definitely towards the leftward directions. If it is offering towards the right, it is assisting the motion. It will try to increase the motion, but that is not the property called viscosity. That may be some other property that is beyond the scope of the syllabus. See my point? Yes or no? Is it clear this question? Same 2021 in 2022 batch, in the year of 2021, there was a demo class. I used to discuss the same thing. Whatever the discussion happened just now, in your class, see, same thing I have discussed in that year also. Next year, in the same 2022, they frame one question. In the regular class, I have taken a good numerical, good question on free body diagram also. Right. In gate, what is the specialty of the gate exam? The new question solving ability. You should be a robot. You should be able to solve good question. You should be a robot, but better than robot, you should be a smart robot. Right. Suppose if you are solving 1,000 problem corresponding to one particular topic, but gate examination is having a superpower that if it is giving 1,000 number one problem, it is not guaranteed that in gate exam you can do that until unless top to bottom full concept is clear. If any concept is missing, you cannot attack gate exam even though you have worked 24 hours per day for 365 days. It is not a UPSC exam in which the hard work will be seen. It is a smart work. Aptitude will be required for the gate exam. From one question, I can frame 1,000 question, right? That should be ability of your also. Whatever the ability of faculty is there here, you should be started developing the same thing. Whatever the question is given, you try to analyze 360 degree of that question and try to answer each and every possible question of that no respective questions, right? Like just now I have no asked one question: what should be the viscous force exerted by L2 onto the L1 towards the right? Are you getting my point? Can I move to the next topic? If I would have not discussed the free body diagram, simply if I just assume that you know each and everything, and just like reading the book, I have started my PPT and start telling you that just note on the viscosity, just note on the Newton's law of viscosity, just note on each and everything without telling you the free body diagram at a microscopic level, this question would have not been answered by 90% of the students. Only 10% of the students who worked really hard, they are very very smart, they follow textbook, they know each and every fundamental, then only they can able to answer. Otherwise, I would have discussed this problem earlier. That's why almost all the students were able to answer this question, right? Because in gate exam, every question will be new. The moment you just open the laptop, means your screen, the question will not be seen before. You have to solve, you have to apply aptitude within 2 to 3 minutes there itself, and that is called a huge amount of pressure, blunder, mistakes will be there. And gate exam is nothing but it is very well known in whole world for doing the lot of silly mistakes just because of pressure. If you know that question before only, then you can attack that question with the what? Very, very calmly, very easily. And that is what the specialty about my classes. Before gate exam, all the question will be discussed in my classes. The future question you say, or upcoming question you say, upcoming unknown topic you say, uncovered topic you say, will be covered in my classes before the gate exam. That's why in fluid mechanics and strength of material, no question mark will be there that you will be having a new question. All the questions will be discussed already in the classes. Now, moving on to the next topic, note down. Note on these particular things which are written in the slide, then we will discuss. Now, guys, just note down. Note on one topic called Newton's law of viscosity. Newton's law of viscosity. Now, what is the meaning of Newton's law of viscosity? Newton's law of viscosity. According to this, shear stress at a distance y from a fixed wall is directly proportional to rate of angular deformations. Rate of angular deformations. See, in the strength of material, deformation is important, but here rate of deformation is important. The diagram will be inverse like this: L1, L2. Then what will be there? Definitely, it should be towards the L1. See, uh, Again, if you are reversing, that should be the layer 2, for example. This will be the layer number 1. The layer 2 is having more velocity, it will offer here, and onto the here, it will be like this. Tau will be directly proportional to du by dy, or directly proportional to d theta by dt. If you remove the proportionality constant, you are going to get mu times of du by dy. That proportionality constant will be called as dynamic viscosity, absolute viscosity, coefficient of viscosity. Three names are there. The fluid which follow Newton's law of viscosity is called Newtonian fluids. Otherwise, they will be called as non-Newtonian fluids. If I plot tau versus du by dy, tell me this graph will be linear or non-linear? Y is directly proportional to x. The graph will be linear. And whatever the slope of this graph will be there, this slope will be called as viscosity. Because y is equal to what? Mx, where m is what? Slope. M is what? Mu. Slope will become what? Viscosity. What is the example of Newtonian fluids? Air, water, mercury, petrol, etc. Du by dy is basically a velocity profile here. Slope of velocity profile. This is the what? What we have the theta dot, which is nothing but du by dy. The rate of a slope, which is nothing but the slope which is given from the vertical. The slope of the velocity profile is nothing but what? Du by dy. So shall we stop it here? Is it sufficient enough? Tell me guys. The session actually is planned for basically 1 hour, but I extended. Try to please revise it. Anyway, whenever we are going to start fluid mechanics, again I will be starting from the starting. So those who are not able to understand, no need to get panic. Each and everything will be clear. Are you getting my point? If you have just noted down, you can leave for the day. Right? Thank you all. All of you have noted down? I think done, right? Okay. Okay, guys, thank you.